the double-slit experiment. You fire a single electron at a barrier, one electron, one particle, one point in space. It goes through and somehow hits every place on the wall at once, not because the equipment is broken, because that is how reality works when no one is watching. Thomas Young first demonstrated the strangeness at the Royal Institution in London in 1801. He sent light through two slits and recorded the interference pattern it left behind, the rippling, alternating bands that only a wave can produce. When 20th century physicists repeated the experiment with electrons, they expected something different. Electrons are particles. Particles make two bands, one behind each slit. Instead, they got the interference pattern, the mathematical signature of a wave produced by a single particle with nothing to interfere with. The University of Bologna confirmed it definitively in 1974. Physicist Pier Giorgio Merli fired electrons one at a time, minutes apart, with no two electrons present simultaneously. There was nothing for each electron to interact with. And yet, across thousands of individual shots, the interference pattern assembled itself on the screen, exactly as if each electron had passed through both slits at once. Hitachi physicist Akira Tanomura replicated this in 1989 with detectors sensitive enough to register each individual impact. Every single landing point was random, but the collective pattern was not. It was the interference pattern, again, built one particle at a time from what should have been randomness. Then researchers added a detector, a device to record which slit each electron actually used. They changed nothing else about the physical apparatus. And the interference pattern vanished completely. The electrons became particles again. Two bands, one behind each slit, exactly as expected. The act of observation produced a 100% change in the behavior of the particle. Not a small statistical nudge, total behavioral reversal caused by nothing except the fact of being watched. Richard Feynman said in his 1965 Messenger lectures that the double-slit experiment has in it the heart of quantum mechanics, and in reality contains the only mystery. That framing was not rhetorical, it was precise. Physicist John Wheeler deepened it further with his delayed choice variant in 1978, showing that the decision to observe or not observe could be made after the electron had already passed through the slits, and the electron's behavior changed retroactively. The future observation rewrote the past trajectory. The strangeness does not stop at the subatomic. Researchers at the University of Vienna replicated the effect with C60 Buckminster fullerene molecules in 1999 and with objects containing nearly 2,000 atoms in 2019. The boundary between quantum weirdness and classical solidity keeps moving, and no one has found the wall. The Copenhagen interpretation, dominant since 1927, holds that observation simply means physical interaction. A photon, a detector, any particle that carries information away from the system. Consciousness is not required. When physicists say observed, they mean measured, and the mathematics of decoherence explains why large objects do not visibly behave this way. The strangeness is real, but it is contained, and it need not disturb our picture of the everyday world. But the Copenhagen interpretation never explains why measurement causes collapse. It describes what happens with extraordinary precision. It declines to say why. And the harder you push on the distinction between a physical interaction and a conscious observation, the harder it becomes to draw a clean line between them. Some physicists, including Eugene Wigner, have argued that wave function collapse requires a conscious observer, not merely a detector. In the many worlds interpretation, the wave function never collapses at all. Every possible outcome occurs in a branching universe, which means the version of you reading this is one of an uncountable number, each existing in a universe that formed when someone, somewhere, looked. Does the universe exist in a definite state when no one is watching? And if every quantum event spawns a new branch of reality, which one is the real you? But if observation shapes reality in the present, what happens when that power reaches backward, into the past? The quantum eraser. A particle lands on a screen. The experiment is over. The impact is recorded. And then, 10 nanoseconds later, a decision is made about a measurement that happened before the particle arrived. And the particle's past behavior changes, not the record, the behavior itself. Physicist Yoon Ho Kim and colleagues published the Delayed Choice Quantum Eraser Experiment in January of 1999 in Physical Review Letters. It built on a theoretical framework John Wheeler had proposed in 1978, but had never been physically realized. What Kim's team demonstrated was this, that erasing which path information after a particle had already landed could retroactively restore the interference pattern that should have been impossible given what the particle had done. The future measurement, made after the event had concluded, determined what the past event had been. The setup used entangled photon pairs. One signal photon traveled through the double slit while its entangled partner, the idler photon, was routed to one of 5 detectors after the signal photon had already hit the screen. Detectors D3 and D4 preserved which path information. Detectors D1 and D2 erased it. When the idler photon hit D3 or D4, the already landed signal photons showed no interference pattern. When it hit D1 or D2, the already landed signal photons showed interference fringes. The signal photons were already on the screen. Their fate had supposedly already been decided, and yet their pattern changed based on a measurement made afterward. The time delay was not accidental. It was engineered precisely so that the idler photon's detection occurred after the signal photon had already landed, removing any possibility that the signal photon could have known its path in advance. Physicist Brian Greene described the experiment in The Fabric of the Cosmos in 2004 as one of the most strikingly strange experiments in all of physics. The Australian National University replicated it in 2015 using a helium atom interferometer and obtained identical results. John Wheeler himself, whose thought experiment inspired the design, wrote that the result denies any simple picture of what is really happening between observation and observation. The result is fully consistent with the many worlds interpretation. In that framework, no paradox exists because every measurement outcome occurs in a separate branch, and what appears to be retroactive change is simply which branch you find yourself inhabiting. No information travels backward in time. The correlations between entangled particles cannot be exploited to send a signal to the past. The mathematics, from this view, is entirely self-consistent and requires no new physics. But the interference fringes in the already landed signal photons are physically real data points on a detector screen. They are not a mathematical artifact. The pattern that should not be there, given what the particle did before the later measurement, is measurably, undeniably present. The math may be consistent. The image is not easy to sit with. If the many worlds interpretation is correct, supposedly the quantum eraser suggests that which branch of reality you inhabit is not fully fixed at the moment of an event. It is fixed at the moment of observation, which may come later. Could your past, in some physically meaningful sense, remain unsettled until someone looks? And if the future shapes what the past was? How many versions of your personal history are simultaneously real right now, waiting for a measurement that hasn't yet been made? From laboratories in South Korea measuring the behavior of light, we cross the Atlantic to hospital rooms in the United Kingdom measuring something far harder to quantify: the experience of being dead. The AWARE study. The patient's heart has stopped. The electroencephalogram is flat. By every clinical measure, the person on the table is dead. And then, after resuscitation, they describe watching their own surgery from the ceiling in accurate detail from an angle no living person lying on that table could ever have had. Dr. Sam Parnia, then at Southampton University Hospital in England, launched the AWARE study, Awareness During Resuscitation, in 2008. It was the largest scientific investigation of near-death experience ever conducted. Parnia's methodology was specific and deliberately skeptical. Visual targets, images placed on shelves positioned to be visible only from above the body, were installed in cardiac arrest resuscitation rooms across 15 hospitals in the United Kingdom, the United States, and Austria. A patient would need to have been genuinely above their own body to see them. Parnia published results in the journal Resuscitation in 2014. 2,060 cardiac arrest patients were enrolled across those 15 hospitals. 330 survived and were interviewed. 140 reported some form of awareness during resuscitation. 9% described features consistent with near-death experience. And one verified case, a 57-year-old man, case 2 in the published results, accurately described the resuscitation room layout, the specific actions of staff, and particular equipment use during a period of confirmed flatline with no discrepancies from the medical record. The 1991 case of Pam Reynolds had already established the stakes. During a procedure called hypothermic cardiac arrest, body cooled to 60 degrees Fahrenheit, brain surgically drained of blood, flatline electroencephalogram confirmed and documented, Reynolds accurately described a surgical saw she had never seen before and overheard a conversation about the size of her femoral arteries. Both details were confirmed by the surgical team. Both occurred during the documented flatline window. Pim van Lommel's 2001 study, published in The Lancet, followed 344 cardiac arrest survivors in the Netherlands. 18% reported near-death experiences. Of those, several provided verifiable out-of-body perceptions. Van Lommel concluded that the near-death experience cannot be explained by changes in the brain. The University of Virginia's Division of Perceptual Studies, founded by Ian Stevenson, has documented over 800 cases with verifiable elements since 1961. The standard objection is that memories form during brief partial consciousness in the recovery phase, assembled from overheard conversations before or after the flatline window. Mainstream medicine attributes near-death experiences to oxygen deprivation causing neural excitation, REM intrusion, dream state bleeding into waking consciousness during physiological crisis, or the release of endogenous neurochemicals. Neurologist Kevin Nelson proposed REM intrusion specifically in a 2011 study in Neurology as the primary mechanism, but REM intrusion cannot account for veridical perceptions. To accurately describe a specific surgical instrument, a specific conversation, or the specific layout of a room you are lying unconscious inside from a vantage point above your own body, you require sensory access. REM intrusion does not provide sensory access. It provides internally generated imagery. Those are not the same thing. If any near-death perception is genuinely veridical, genuinely accurate about an external event during confirmed zero brain activity, then consciousness is not straightforwardly produced by the brain alone. It may be hosted by it, which raises a question medicine does not currently have a framework to answer. What is doing the perceiving when the organ of perception is offline? And if perception can continue without a functioning brain, what happens when the brain goes offline permanently. From the moment of death, we move to something stranger still. The memories that arrive before a life has even been lived. The Stevenson cases. A 3-year-old in Lebanon points at a village he has never visited and says he used to live there. He gives a name. He describes the house. He describes how he died. The family drives to the village. The man he described exists. The house matches. The cause of death matches. The child has a birthmark exactly where the fatal wound was. Dr. Ian Stevenson, former chair of psychiatry at the University of Virginia, spent 40 years investigating over 3,000 cases of children claiming past life memories. His methodology was systematic and documented across peer-reviewed publications, beginning with 20 cases suggestive of reincarnation in 1966. His successor, Jim Tucker, continues the work today, publishing in mainstream medical journals. The cases concentrate in children between ages 2 and 5 who typically stop discussing the previous life by age 7 or 8, often corresponding precisely with starting school. Stevenson documented over 200 cases where children had birthmarks or birth defects that corresponded to wounds on the deceased individual they claimed to be, verified against death certificates and autopsy reports. The correspondence was anatomically precise, not general, not approximate. The scar was at the documented entry point of the documented fatal wound on the documented individual the child had named before any investigation began. The case of Shanti Devi, recorded in India in the 1930s, was investigated by a committee organized by Mahatma Gandhi. The girl claimed to be a woman named Lokdi Devi, who had died in childbirth in Mathura, 145 kilometers away. She provided accurate details about Lugdi's home, husband, and family, including details that were deliberately withheld from her by the committee until she identified them herself. In peer-reviewed analysis published in the Journal of Nervous and Mental Disease in 1977, Stevenson found that 35% of his cases involved verifiable claims confirmed to be accurate before any investigation had begun. Jim Tucker's 2013 book, Return to Life, documents American cases. In one, a child from Louisiana identified his past life family from a group photograph, named his former agent, and accurately described his death in a fire on a Hollywood set. All details were verified. The University of Virginia database now holds over 2,500 cases meeting Stevenson's evidentiary criteria across more than 40 countries. Psychologists attribute these cases to cryptomnesia, forgotten information surfacing as apparent memory, combined with parental encouragement, motivated pattern matching by researchers, and the cultural prevalence of reincarnation belief in South and Southeast Asia, where the majority of cases originate. Cognitive psychologist Nicholas Spanos proposed past life role-playing as an explanation for children who discuss previous lives in elaborate detail. But cultural expectation does not produce a pigmented scar at the precise anatomical coordinates of a documented bullet entry wound on a specific, verifiable, previously unknown, deceased individual. Stevenson noted that most families in his cases were hostile or embarrassed by their child's claims, not encouraging them. Motivated suggestion requires motivation. Most of these families had none. If even a fraction of the birthmark cases represent genuine information transfer, information a child could not have obtained by any normal means, then identity persists in some form across the boundary of a single body. Which raises a question that physics has not ruled out and medicine has not answered. If the self is a pattern rather than a substance, what prevents that pattern from continuing somewhere else? Could the version of you reading this be a continuation rather than a beginning? The Stevenson cases suggest a transfer that happens across lifetimes, But some researchers now ask whether transfers are also happening between parallel versions of the same life, right now, in real time. The Mandela effect. Hundreds of thousands of people remember the same thing, not vaguely, specifically. The exact words, the exact image, the exact detail. And they are all wrong in precisely the same way about precisely the same thing, having never met each other. Paranormal researcher Fiona Broome coined the term Mandela effect in 2009 after discovering that she and numerous conference attendees shared the identical false memory of Nelson Mandela dying in prison in the 1980s. He did not. He was released in 1990 and died in 2013. What followed was the identification of dozens of similarly distributed, similarly specific false memories shared by millions of unconnected individuals across different countries, demographics, and generations, people who had never interacted and had no common mechanism for arriving at the same specific wrong answer. The Berenstain Bears case is among the most documented. Millions of readers distinctly remember the children's book series spelled Berenstain. The actual spelling has always been Berenstain. The false memory correlates strongly with childhood reading and is distributed equally among people who had no contact with each other and no shared media exposure that could explain the convergence. Then there is Rich Uncle Pennybags, the Monopoly Man, remembered by the majority of respondents as wearing a monocle. He has never worn one in any version of the game's artwork. The false memory is so widespread, it has been used in protest signs outside congressional hearings, held by people who apparently felt confident enough in the misremembering to make it public. Memory researcher Elizabeth Loftus demonstrated in her landmark 1974 study in the Journal of Verbal Learning and Verbal Behavior that false memories can be implanted with high consistency through leading questions. But her methodology required active suggestion. Someone had to plant the seed. The Mandela effect cases involve no common suggestion mechanism. A 2022 study published in Psychological Science by MIT researchers found that misinformation spread through social networks does create convergent false memories, but timeline analysis shows that many Mandela effect memories predate the internet discussions about them. The Star Wars misquote is another example. The line remembered as Luke, "I am your father," when the actual line is "No, I am your father," is recalled in the wrong form by the majority of people who have seen the film, including people who encountered it long before any online discussion existed. Cognitive neuroscientist Chris Moulin, who studies déjà vu and memory at the University of Grenoble, has noted that genuine group confabulation at this scale, with this specificity, challenges our model of how false memory propagates. And these false memories resist correction in a way typical false memories do not. People told the Monopoly Man has no monocle frequently respond with increased certainty that they remember him wearing one. The brain is reconstructive, not reproductive. It fills gaps with plausible substitutions. The Berenstain confusion is explained by the prevalence of Stein endings in surnames. The monocle misattribution comes from visual conflation with similarly dressed characters. These are pattern completion errors, independent but converging on the same logical substitution because human brains are similarly wired. That is the mainstream explanation, and it is a good one. But logical substitution explains convergence toward the plausible. The Monopoly Man's monocle is not a plausible completion of his costume. He wears neither glasses nor a monocle in any version of the artwork. There is no adjacent figure to cause conflation. Thousands of people independently added the same specific accessory to a figure who never had one, and resist being corrected. According to some interpretations of the many worlds interpretation, parallel timelines branch constantly with most observers existing in branches where histories are nearly, but not perfectly, identical. If consciousness can occasionally carry a residue of memory from a branch it has migrated from, individuals might retain accurate recollections of a version of reality that no longer matches the one they currently inhabit. Not a conspiracy, possibly something more like a watermark. Could the Mandela effect be the specific texture of what it feels like to be in a timeline that isn't quite yours? The Mandela effect asks what happens when your memory doesn't match your timeline, but there is a theorem in physics that asks something darker. What if you died in every other version of reality, and this is simply the only one left? Quantum immortality. You point a quantum gun at your head. It fires based on a quantum event, a radioactive decay with exactly 50% probability of occurring. In the branch where it fires, you die. In the branch where it doesn't, you survive. You pull the trigger 1,000 times. By ordinary probability, you should be dead. But you are always in the branch where you survived. You have no choice. Dead branches don't have observers. Philosopher Hans Moravec first described the quantum suicide thought experiment in 1987. MIT physicist Max Tegmark formalized it as a serious consequence of the many worlds interpretation in a 1998 paper in Physics Letters A, arguing that if many worlds is correct, an observer will subjectively always find themselves in the branch where they survived any quantum lethal event, because only surviving branches contain the observer to do the finding. Hugh Everett III, who published the Many Worlds Interpretation in 1957 in Reviews of Modern Physics as his Princeton doctoral thesis, reportedly believed in quantum immortality personally and was said to be genuinely unconcerned by his own mortality. A 2013 informal poll of 33 physicists at a Quantum Foundations conference administered by philosopher David Chalmers found 61% preferring many worlds or related no-collapse interpretations over Copenhagen. This is not a fringe position. It is the plurality view among working physicists at the research frontier. The anthropic principle, first formalized by Brandon Carter in 1973, establishes that observers can only observe conditions compatible with their own existence. We cannot observe our own death regardless of its probability, not because death is impossible, but because observation requires an observer, and a dead one cannot observe. Nick Bostrom's doomsday argument, published in 2002, uses the same anthropic framework to calculate extinction timelines. The same logic implies that the observer always finds themselves in the surviving branch, by definition, across any number of events. Tegmark notes in Our Mathematical Universe, published in 2014, that quantum immortality would not feel miraculous from the inside. It would feel like a long sequence of narrow escapes, ordinary luck, situations that could have gone either way. The thought experiment is also philosophically unfalsifiable from the inside. You cannot design a test that would disprove it, because the inside always survives. Most physicists, including Tegmark himself, reject quantum immortality as a practical consequence. The objection is decoherence. The process by which quantum superposition is destroyed by interaction with the environment means that macroscopic events like bullets are not quantum events in the relevant sense. A bullet is classical physics. The quantum randomness that generated it has decohered long before it reaches a body. Quantum branching does not provide a surviving version for every macroscopic lethal event. But decoherence is a spectrum, not a wall. And the anthropic principle does not stop at the quantum scale. It operates regardless of the mechanism. However, an ending arrives, quantum or classical. By definition, you remain in the branches where it didn't. The real version of quantum immortality, according to this view, may not be a gun. It may be the entire shape of your life so far. Every close call, every accident that killed someone nearby and not you, every diagnosis that turned out wrong. In a branching multiverse, there are versions of you that didn't walk away from each of those moments. Could it be that you are always the version that did? Not because you're lucky, but because the other versions simply are not here to notice? From the theoretical physics of Cambridge, Massachusetts, we travel to Chennai, India, and San Diego, California, where a neurologist discovered that the brain maintains a perfect operating model of you that functions entirely independently of your body. The phantom limb. The soldier's arm was amputated above the elbow in 1864. 40 years later, he still felt it. Not vaguely. He felt the wedding ring on the finger that no longer existed, the itch he could not scratch, the hand clenching into a fist he could not open. The arm was gone. The experience of the arm was not. Civil War surgeon Silas Weir Mitchell first documented phantom limb syndrome systematically in 1871 in Injuries of Nerves and Their Consequences. He found phantom sensations in nearly 90% of upper limb amputees and 70% of lower limb amputees, the most common post-amputation neurological experience and one that had been noted by soldiers and surgeons for centuries without explanation. The mystery was not merely that the sensation existed, it was that the sensation was specific, spatially precise, the ring on a particular finger, the pain in a particular joint. A structure with no physical substrate generating experience with extraordinary anatomical detail. UC San Diego neurologist V.S. Ramachandran addressed part of the mystery in 1992 with a device of almost comic simplicity, a mirror box. By arranging a mirror so that the reflection of the intact limb appeared where the missing limb would have been, and having patients move the intact arm while watching the reflection, Ramachandran could relieve phantom limb pain. The results were published in Nature and established something significant. The brain's body map, not the peripheral nervous system, was generating the phantom experience. The ghost was in the software, not the wiring. What deepened the mystery was what Ramachandran and Herstein found in cases of congenital limb absence, published in Proceedings of the Royal Society B in 1998. People born without limbs sometimes report phantom sensations for the limbs they never had. There was no physical arm to lose, no experience of having an arm to remember, no nerve endings that had once carried arm signals. Yet the phantom was present. The body map, it seemed, was partially innate, not learned from physical experience, but present before physical experience had a chance to shape it. Oxford University fMRI studies by Floor and colleagues in 1995 showed that the cortical area previously devoted to an amputated hand is rapidly colonized by adjacent brain regions after amputation. Yet phantom sensation persists independently, suggesting it arises from a level deeper than cortical real estate. Patients report that the phantom moves, gestures, and responds independently of intention. Phantom arms reaching toward ringing phones before the conscious mind remembers the arm is gone. In some amputees, touching the cheek produces sensation in the missing hand, because the face and hand representations share cortical proximity. The brain has literally rerouted touch data from one surface to a ghost. Philosopher Thomas Metzinger, in Being No One, published in 2003, uses phantom limb to argue that the self is itself a controlled model, a hallucination generated by the brain, and phantom limb is simply what the model looks like when the data it was built from disappears. Standard neuroscience explains phantom limb entirely through neural plasticity and residual signaling. The somatosensory cortex continues generating output after amputation from adjacent neural regions. It is a hardware artifact, Wiring with nowhere new to go produces signal in the old pattern. No metaphysics required, but congenital phantom limbs, sensations in limbs that were never there, never wired, never physically represented, suggest the map precedes the territory. The brain has a body schema that apparently exists prior to and independently of the body it supposedly represents. If the brain maintains a precise model of the self that operates independently of physical anatomy, generating real experience in the absence of real structure, then what happens to that model when the brain itself ceases to function? Metzinger asks whether the self model could, under certain conditions, decouple from the neural substrate that runs it. Not a soul in any traditional sense. Possibly a pattern running on something else. Could the experience of being you be more portable than it appears? From the neuroscience of San Diego, we move to a laboratory in Brooklyn, New York, where researchers in the 1960s found evidence that the mind reaches not just beyond the body, but beyond the present moment entirely. The Maimonides Dream Experiments. You are asleep in a laboratory in Brooklyn. In another room, a researcher opens a sealed envelope and stares at a randomly selected image. An image chosen after you fell asleep by a process no one could have predicted. In the morning, your dream transcript is given to a judge who does not know the target. The judge identifies the match, not once, consistently, across hundreds of trials. Psychiatrist Montague Ullman and psychologist Stanley Krippner ran a formal dream telepathy laboratory at Maimonides Medical Center in Brooklyn from 1966 to 1972. The design was rigorous and specifically built to eliminate sensory leakage. Targets were randomly selected after subjects fell asleep, isolated behind multiple layers of control from any possible normal communication channel, and matched against dream transcripts by judges who were blind to the targets. Results were published across peer-reviewed journals and collected in the book Dream Telepathy in 1973. The first formal session in 1966 produced a hit rate that judges scored at 7 out of 8 for correct matching. Targets included Vincent van Gogh's The Starry Night. The subject described whirling night skies, and a painting by Edgar Degas featuring horses. The subject described horses. In Krippner's 1970 experiment with subject Alan Vaughan, the target was Salvador Dali's The Sacrament of the Last Supper. Vaughan's dream transcript, submitted before the target was revealed, included apostles, a long table, and imagery of communal eating. A 1985 meta-analysis by Irvin Child, published in American Psychologist, reviewed all Maimonides experiments, found an overall hit rate significantly above chance at a p-value below 0.05 across combined studies, and called the methodology sound. The Ganzfeld experiments, pioneered by Charles Honorton from 1974, used sensory deprivation to induce dreamlike states during telepathy trials. A 1985 meta-analysis by Honorton and Hyman found an overall hit rate of 34% against a 25% chance expectation across 28 studies. A 2016 analysis by Sherwood and Rowe, published in the International Journal of Parapsychology, found hit rates 6.6% above chance across 79 independent studies using the Ganzfeld protocol. Psychologist Daryl Bem at Cornell University published Feeling the Future in the Journal of Personality and Social Psychology in 2011, reporting 9 experiments with 1,000 subjects showing statistically significant responses to events before they happened, including subjects recalling words they would later study before they had studied them. Neuroscientist Francis Crick, co-discoverer of the structure of DNA, noted in The Astonishing Hypothesis in 1994 that the dreaming brain is in a state of offline processing during which information from outside normal sensory channels cannot be ruled out. Psychologists attribute above-chance results to methodological flaws. Sensory leakage between sender and receiver, unconscious cues in judge evaluation, publication bias from unreported failed experiments, and the multiple comparisons problem. Under more stringent controls, the argument goes, the effect diminishes. But across 79 independent studies reviewed in 2016, the effect has shrunk. It has not gone to zero. A signal that survives that many attempts to eliminate it is not obviously nothing. If the dreaming mind can access information about events that have not yet occurred, or about events physically isolated from it, then time, at the level of consciousness, may not run in only one direction. Not telepathy in any science fiction sense. Something more like a receiver tuned to a frequency that plays slightly ahead of the present. And if that is possible at any scale, then every morning you wake from sleep, you may have already been somewhere you cannot quite remember going. Could dreaming be the state in which the boundary between timelines is most permeable? Dreams reaching forward in time from a single laboratory in Brooklyn. But from a cosmology building in Davis, California, a theorem reaches further, suggesting that the self doing the dreaming may not have a past at all. The Boltzmann brain. In an infinite universe with infinite time, the laws of thermodynamics guarantee that random fluctuations will eventually produce anything, including a fully formed conscious mind suspended in space, complete with false memories of a life it never lived, waking up for the first and only time, absolutely convinced it has a past. Ludwig Boltzmann proposed in 1895 in Annalen der Physik that the observable universe might itself be a statistical fluctuation in an otherwise featureless void at maximum entropy. The modern version of his nightmare emerged from inflationary cosmology in the early 2000s. Andreas Albrecht and Lorenzo Sorbo formalized it in a 2004 paper in Physical Review D, calculating that in de Sitter space, the geometry that our accelerating universe is currently approaching, spontaneously fluctuated observers complete with false memories should not merely occur, but should be overwhelmingly common on eternal timescales. In 2007, physicists Freeman Dyson, Matthew Kleban, and Leonard Susskind described Boltzmann brains as the most embarrassing problem in cosmology in the Journal of High Energy Physics. Not a curiosity, not a footnote, the most embarrassing problem. Caltech cosmologist Sean Carroll discusses Boltzmann brains in From Eternity to Here, published in 2010, as a genuine crisis for cosmological models, writing that most observers in any eternal cosmology would be Boltzmann brains, not evolved creatures in young universes. Barkut Don Page at the University of Alberta published Is Our Universe? Likely in 2006, arguing that any cosmological model predicting more Boltzmann brains than ordinary observers is self-defeating. Because Boltzmann brains cannot trust their own observations, including the observations used to build the cosmological model in the first place. Philosopher Bertrand Russell raised a structurally parallel argument in 1921. The universe could have been created 5 minutes ago, complete with memories, fossils, and starlight already in transit, and there is no logical refutation available from inside that universe. The only escape from Boltzmann brains is a cosmological model in which genuine evolution of complexity is more probable than random fluctuation, which requires explaining why our universe has precisely the physical constants necessary for that complexity to arise, which loops back into the fine-tuning problem with no obvious exit. Most cosmologists treat Boltzmann brains as a reductio ad absurdum, a sign that a cosmological model is incorrect, not a genuine description of the observer's situation. Any model predicting Boltzmann brains outnumber real observers is rejected as physically unacceptable, not because the problem has been solved, but because the alternative is epistemically intolerable. It would make all scientific observation meaningless. But epistemically intolerable is a human preference. It is not a physical argument. The mathematics does not care whether we find the conclusion comfortable. Boltzmann himself found it so disturbing that, according to historical accounts, it contributed to the depression that ended his life in 1906. If the laws of physics genuinely permit spontaneous conscious observers with entirely false histories, then there is no observation you can make right now that would prove you are not one. Your memories of the previous 8 items on this list may have assembled from thermal noise 10 seconds ago. Your certainty that they didn't is itself one of those memories. The question is not whether this is likely. According to some interpretations of eternal cosmology, it is overwhelmingly likely. The question is whether the distinction is detectable from the inside, and supposedly, it is not. From the terrifying possibility that your entire history is thermal noise, we arrive at the deepest question of all, the one that has remained completely unanswered since the first scientists thought to ask it. The hard problem of consciousness. Everything science has ever accomplished, mapping the genome, splitting the atom, photographing a black hole, worked by explaining mechanism, how the parts produce the function. There is exactly one problem in the history of science that has not yielded to this approach. Not because the experiments are difficult, because the question may be a different kind of question entirely. Philosopher David Chalmers drew the distinction in a 1995 paper in the Journal of Consciousness Studies, later expanded in The Conscious Mind in 1996. He separated the easy problems of consciousness, explaining attention, memory, sleep, the functional mechanisms of mind, from what he called the hard problem. The easy problems are not actually easy. They will take decades to solve, but they are, in principle, solvable by explaining mechanism. The hard problem is different. It asks not how the brain processes information, but why any of that processing feels like anything at all. The paper has been cited over 8,000 times. The problem has not moved. Thomas Nagel established the philosophical foundation in his 1974 paper, What Is It Like to Be a Bat?, published in the Philosophical Review. His argument was precise. Even if you possessed complete physical knowledge of a bat's echolocation system, every neuron, every frequency, every neural pathway, you would still not know what it feels like to be the bat. Subjective experience is not reducible to physical description. It is a different kind of fact. The stakes of this distinction are severe. You could, in principle, build a perfect physical replica of a human brain, every synapse, every electrochemical gradient identical, that processes all the same information and produces all the same behaviors, but with nothing it is like to be it. No inner sensation of red when it processes the wavelength of red light. No experience of pain when it signals distress. Philosophers call this entity the philosophical zombie. And according to this view, the existence of philosophical zombies is conceivable, which means the gap between physical function and subjective experience is real, not merely apparent. Nobel laureate Francis Crick and neuroscientist Christoph Koch acknowledged in a 2003 paper in Nature Neuroscience that 30 years of collaboration had produced a detailed map of the neural correlates of consciousness, but had not answered why the mechanism produces experience. They were studying correlates, not causes, and the why remained outside the reach of their methods. Giulio Tononi's integrated information theory developed from 2008 onward, attempts to measure consciousness as a mathematical quantity called phi. But even its proponents acknowledge it describes the distribution of consciousness, not why information integration produces experience rather than simply more processing. A 2019 paper in Frontiers in Human Neuroscience by Kleiner and Tull concluded that there is no known physical theory that predicts or explains the existence of conscious experience. Philosopher Frank Jackson's Mary's Room thought experiment, published in 1982, crystallizes the problem. A scientist raised in a black and white room knows every physical fact about color vision. She knows the wavelengths, the cone cells, the neural pathways. When she finally leaves the room and sees red for the first time, does she learn something new? If yes, then physical facts do not exhaust all facts. There is something left over. Daniel Dennett, in Consciousness Explained, published in 1991, denies the hard problem entirely, arguing that subjective experience is a cognitive illusion. There is no inner light, only the functional report of one. Chalmers's response has been consistent. Dennett has explained the problem away rather than explained it. Neuroscience holds that consciousness is an emergent property of neural complexity and that a full mechanistic account is achievable in principle, just as digestion and immunity were once mysterious and are now well understood. But emergence has never produced something categorically different in kind from its components. Water is wetter than hydrogen or oxygen. It is not a different category of thing. Consciousness, if it is what it seems to be from the inside, is not merely more complex processing. It is the fact that there is something it is like to do the processing, and that fact has no physical explanation, even in outline. If consciousness cannot be produced by any physical arrangement, if the hard problem is genuinely hard rather than merely temporarily hard, then mind may not be a product of matter at all. It may be a feature of reality at a more fundamental level, not supernatural, prior to the distinction. The thing that was present before anything was observed. Which brings us all the way back to the electron at the double slit, the patient with the flatline electroencephalogram, the child pointing at a house in a village he has never seen, all of them pointing at the same gap. Could the thing doing the pointing be the one thing physics has never successfully placed inside its equations? Here is what connects all 10 of these. The double-slit experiment says reality is not fixed until observed. The quantum eraser says the past can be shaped by a measurement that hasn't been made yet. The AWARE study says something continues to perceive after the brain flatlines. The Stevenson cases say identity transfers across bodies, carrying marks of how the last one ended. The Mandela effect says your memory of your own timeline may not match the timeline you're currently in. Quantum immortality says you are always, by logical necessity, in the branch where you survived. The phantom limb says the brain's model of you operates independently of the body it represents. The Maimonides experiments say the dreaming mind reaches beyond its own moment in time. The Boltzmann brain says your entire history may have assembled from thermal noise seconds ago. And the hard problem says not one scientist or philosopher on Earth can explain why any of this is happening to someone. These are not fringe ideas. They are published physics, peer-reviewed neuroscience, and open problems at the center of the most rigorous disciplines humanity has ever constructed. The mainstream explanation for each of them exists. You heard it every time. And every time you felt the edge of what it left unaccounted for. That edge is the same edge. Across quantum mechanics, clinical medicine, cognitive science, and cosmology, the same gap keeps appearing. The gap between the mechanism and the experience of the mechanism. Between the physical event and the fact that there is something it is like to witness it. Between the equation and the one reading it. Most people encounter these questions in a textbook summary and walk away with the official conclusion. You stayed long enough to feel the gap between the explanation and the thing being explained. That is a specific kind of attention. The kind that notices when an answer accounts for the data but not the strangeness. This channel exists in that gap. Every item we cover lives in that space between what the evidence shows and what the explanation reaches. That is not a conspiracy. That is the frontier. And the people who belong here are the ones who cannot stop asking what is on the other side of the official answer. Subscribe, and you are not signing up for content. You are locking in your place in the archive of everything that doesn't fit the explanation we have been given. Now go to the comments. One number. The item that made the floor feel less solid beneath you. Not the most interesting, the most destabilizing. Defend your choice. Convince the rest of us. The floor is yours. You fired one electron at two slits. It went through both. You looked, and it chose. Every item in this list is a different angle on the same impossibility, that the thing doing the observing cannot be fully accounted for by what it observes. The double slit, the flat-lined brain, the child pointing at a house in a village he has never visited. All of them led back to the same wall. You are a witness to a reality that changes when you look at it. That includes the reality of your own past. The question was never whether you died in another timeline. The question is whether this one is any more certain.